In today's lesson, we're going to be going over all of the string methods that come with the string in Python. So, there's a lot of common ones such as split or upper that you are probably familiar with, but there are also a lot that aren't really that commonly used, and I want to just cover every single one of these. So there are going to be 47 in total, excluding the dunder methods. So in case you're curious about everything you can do with a string, follow along with this video because we're going to be covering 47 of these string methods. For number one, we have capitalize, which means if we have some text and that's in lowercase or uppercase, we can capitalize that. And when we run this, we're going to get hello with a capital H. And if this is in uppercase, it's still going to capitalize that string. Next, we have casefold, which returns a version of the string for caseless comparisons. So pretend you have Mario here that's spelled a bit weird. If we run this, it's going to make sure that we can compare this to another Mario without having to worry about whether this is uppercase or lowercase. So if we duplicate this line and say text2 and change this to Mario like that, as you probably know, this is not going to be equal to this because of the case sensitivity. But if we print both of them, text1 and text2, they're both going to be processed into a version that can be compared without having to worry about the case. Next, we have the center method. So suppose we have some text and we want to call .center on it, provide some sort of number, and that number is going to specify how many characters you want this string to occupy and where you want the text to be centered. And optionally, you can include a character or a string that's going to be placed around the string that you want to center. Number four is count. Suppose you have a string with some sort of substring that you want to count. Here, if we type in abc underscore abc underscore abc and so on, and then we use the method .count with only ab, we're going to get a return of 4 because it's counting all the occurrences of AB in this string. For number 5, we have encode, which allows us to encode a string of our choice. And if we run this, we're going to get the byte version of Elon Musk because we were able to encode that into UTF-8. And you can also provide an optional parameter which says errors, and if you set this to strict, it means that if it cannot encode it, it's going to throw an error, which is good in case you want to make sure that this does become encoded. For number 6, we have the endswith method, which checks that a string ends with a certain letter, such as E. If we check now that apple ends with E, we're going to get a return of true. And this doesn't have to be a single character. It can actually be a tuple of characters, such as E, and we can also say A. So now it's going to check that it ends with either E or A. And if we run that, we're still going to get true. And if we type in appla, it will still be true. But if we type in something such as Z, it's going to return false because neither E nor A was at the end of our string. Number 7, expandtabs. Right here we have a string with some tabs, as you can see by the \t. Using .expandtabs allows us to expand those tabs using spaces. So here I defined a value of 20, which means when we run this, you'll see that we'll get some very long tabs inside our string. Number 8, find. Suppose we have a string that says something silly, such as remember to comment and subscribe. And suppose we want to find the substring of subscribe in this string. Well, we can do that using the text.find method, and it's going to return to us the integer of the first and lowest occurrence of subscribe. So if we have multiple subscribes, it's going to return the first one that it finds. Now, if we run this, we're going to find that subscribe was located at the index of 24. So I went ahead and printed everything after that position, and that returned to me subscribe. Now, if we don't have what we are looking for, such as asdas, it's going to return to us the index of -1. Number 9, format. Here are two different ways we can use this method with strings. The first way is defining some keywords inside the string, followed by some curly brackets, and then typing in text.format followed by the keyword arguments such as subject and action, which I've included in this string. Now, subject is going to be replaced by cat and action is going to be replaced by meow. And the same thing works without having to specify the keywords. Now, when we run both of these, it's going to say cat is doing meow. Next, we have format map, which maps a dictionary to the formatted values that we have in our string. So for example, if we have a dictionary with X and Y, and then we have a string using those values, we can just call text.formatMap coordinates, and it's going to place these values in the given values down here. So if we run this, we'll get that the coordinates are 10 and -5. Number 11, index. Right here we have a string that says astronauts recently discovered a banana on the moon, ? And we want to find the position of banana. Now, recently I showed you that we can use find to find the position of a certain substring, and we can achieve the same thing with index, except index does have one difference, and that is that if we do not find what we're looking for, it's going to throw an error instead of returning to us -1. Number 12, isalnum, which stands for isalphanumeric, and that checks that the string contains letters or numbers, but if it contains something such as an exclamation mark or some other symbol, it's not going to be considered alphanumeric anymore. So right now, if we run this with Hello Kitty 123, it is alphanumeric because it only contains letters and numbers, but if we add an exclamation mark, for example, it's going to evaluate to false because an exclamation mark is neither a number nor a letter. Number 13 is alpha, and that checks that the text is alphabetic only. So if we run this, it's going to return false because Hello Kitty contains numbers, but if we remove the numbers, it's going to evaluate to true. Number 14 is isascci, and that returns to us true if the current string contains only isascci characters. So if we decide to add the symbol such as a copyright mark to our text, it's going to return false to us because that is not part of the isascci table. But if we exclude that, it's going to return true to us. Now for 15, 16, and 17, I decided to bring in my notes for this because these are quite confusing if you don't have them side by side. So what we're covering now is isdecimal, isdigit, and isnumeric. So right now, if you want to make sure that something is actually a number, you can use isdecimal, and that's going to evaluate 1, 2, 3 to true. And if you run that, the first one is going to evaluate to true. But if we decide to evaluate something that is numeric, but not a decimal, such as these crazy symbols here, it's going to evaluate to false. And that is because it is only checking that this is a decimal. Now, isdigit checks for something very similar. It checks that the current string is a digit. And 1, 2, 3, 4, 5, 6, even in these crazy bubbles, is considered a digit, so it's going to evaluate to true. Now, numeric, on the other hand, is going to just evaluate to true if the number happens to be numeric. So all these Japanese numbers do evaluate to numbers, so it's considered numeric. But this does not work if you put it inside here because it is not a digit. Now, the reason I brought all three of these together is just to show you that they actually work in quite similar ways. And that is that isnumeric works with all three, isdigit works with these two, and isdecimal only works with numbers. So what I'm trying to say is that if you wanted to include some numbers inside isnumeric, such as 1, 2, 3, it will still evaluate to true. If you wanted to include some crazy symbols like these ones that are digits, it will still evaluate to true. But this does not work the other way around. So if we take these Japanese numbers and place them inside the isdigit, it's going to evaluate to false because it is not a digit, even though it is numeric. But for the most part of the time, you probably just want to check that it is a decimal, so I would recommend using that. But in case you want to check whether something is numeric or is a digit, you also have that option. Number 18 is identifier. Here we have some text that says test sample, and what this does is check that it is a valid identifier name in Python, in case you want to use it to name a variable, for example. If we run this, we're going to get false because you cannot use dashes in names in Python. If we change it to an underscore, it will work. But if we change this to a one test underscore sample, it will still return false because numbers cannot precede variable names in Python. Number 19, islower. Here we have some text with ABC with A uppercased, and what this does is check that the entire string is lowercased. If we run this, we're going to get false as a return because ABC has a capital A, but if we return it with a lowercase, it's going to evaluate to true. Number 20 is printable. All this does is check that the current line of text is actually printable, and it considers text to be printable if it doesn't contain any escape characters such as new line. If we run this right now, we're going to get false because it contains this escape sequence, but if we return it without that escape sequence, we're going to get true as a return. Number 21 is space. All this does is check that a string only contains space. So if we create this string with a lot of empty space and run the program, we're going to get true as a return because it is only space. Number 22 is title. Istitle checks that the given string is a title. So that video is going to elaborate to true because it is a title. It follows the title syntax. If we type in something such as hello video, it's going to evaluate the false because hello is not uppercased. So all it's really doing is checking that the first letter of each word is uppercased. Number 23 is upper. Here we have a string with bananas in complete uppercase, and all this does is check that the entire string is uppercased. Here we're going to get a return of true because bananas is uppercased. But if we add a lowercase n, it's going to evaluate the false because it is not entirely uppercased. Number 24, join. Right now we have a text of type string and we want to combine some words, for example. So what join does is combine an array of items together using the given string. So this is going to be placed in between each one of the elements that we are joining. And to call it, we just have to say text.join, and we're going to join an array of our choice. So if we run this, we'll get text1-text2-text3. And you will probably see it without this because it is an extra line of code that you don't need, and used instead like this with a dash. And with that, we will still get the same result, but without having to use this extra variable. Next, we have ljust, which aligns the text as far as possible to the left with the amount of space that we've provided. So here we have text.ljust, and I decided to give it 20 characters of space and to fill the remaining with the underscore. So if we run this, we're going to get text and underscore filled for the remaining spots inside this string. Number 26, lower. Right now we have a string that has been uppercased, and all we want to do is convert it to lowercase, and we can use that using text.lower. So uppercase in uppercase is going to become an uppercase in lowercase. Number 27, lstrip. Here we have some text, and pretend you want to remove some from some text. We can do that using .lstrip followed by the keyword or the text that you want to remove from the left side of the string. So if we remove that, we will just have text remaining. And if we do some with some space, it's also going to remove the space in front of text. Number 28 and 29, maketrans and translate. These two tend to go hand in hand when you are working with them, because what maketrans does is create a translation table. So right now what we're saying is that we want to convert this text to a translation table, and to do that we want to make sure that every uppercase B gets translated to this emoji over here. And then we want to use that translation table for the text that we want to print, because right now if we print this text as it is, even if we've created a table, it's not going to do anything. But if we translate it with the table that we've created here, it's going to replace each uppercase B with this emoji. And if we run that, we'll see that 66, or that character, was replaced with this emoji character. And that's why we're going to get this funky string over here. And the cool thing about that is that you can use any new string you want. It can even be that is bacon, baby. And when you run this, we're going to get each one of the uppercase B's replaced with this symbol over here. If you want to have more than just one character converted, you can enter your own dictionary key, and it's going to create a translation table. Number 30, partition. Suppose you have a string such as a plus b equals c, and you want to partition these. In other words, split them at a certain point. You can use the .partition method to make sure that you split this into 3 equal strings at the index of equal. And what that really means is that we're using equals as a separator to tell the program that we want to split this string into 3 parts between the equal sign. So we're going to get back a plus b equals and c. Number 31, removeprefix. Here we have a string that says what's up. And what we want to do is remove the beginning part which says was. To do that, we just type in .removeprefix and all we're going to get back is app. Now for number 32, it's exactly the opposite. We are removing the suffix. So here we have Mr. Everyone and we want to remove 1 from this. So here we'll just type in text.removesuffix with 1, and when we run that, we'll get Mr. Every. Now number 33 is one of the most important ones because it tells you to remember to comment. I'm just joking about that, of course. But here we have a string that says remember to comment, and all we're going to do is replace it with subscribe. So here you can choose a substring that you want to replace and replace it with the current string that you've provided. So if we run that, instead of saying remember to comment, it's going to say remember to subscribe. And optionally, in case you have many occurrences of the same word, you can provide a limit to how many times you want to replace that text. So instead of replacing every occurrence of comment with subscribe, we're only going to replace the first occurrence. So now it's going to say remember to subscribe and to comment. Number 34, rfind. Here we have some text that says a, some text dot a, and what we want to do is find the first occurrence of a starting from the right. So here if we type in text.rfind and we print the position, we're going to get the latter and not the first. If we use the original, we're going to get the first one. And just as before, if you type in something that doesn't exist, you're going to get -1 when you use find. When you use index, you're going to get an error. But what better way to explain that than using the exact same example except with rIndex, which does the same thing as index except it starts from the end and searches in this direction. So if we look for B, it's going to return to us 14 because it's starting from the right side. And again, if you type in something that doesn't exist, it's going to give us a value error. Number 36, rjustify. Here we have some text and we're just going to say text.rjust, and we want to make sure that this string occupies 20 spaces, and we're going to fill the remaining with the underscore. And as you can see in the output, that's what rjust does. Now at this point, you know what partition does. It splits the string into 3, depending on the separator that you've defined. But we also have something called rpartition, which tells the program to start from the right side. So instead of getting text and having this as a divider, we're going to be using the second one instead because it starts from the right side. And if we run that, you'll see text equals text2 equals. But if we remove the r from rpartition, it's going to do it the opposite way. 38 and 39, rsplit and split. But first we're going to cover rsplit. So here we have some text that says this is some special stuff, and what rsplit does is, starting from the right, it splits the string into an array given the separator that we've provided. So as you can see here, we have some space that we decided to use as a separator, so it's going to split each and every one of these words into its own element. And if we run that, we'll get this is some special stuff because we used the space as a separator. And the same thing goes for this website over here. We decided to use a dot as a separator, so it separated www, website, and com. Now text.split is the exact same thing, except it evaluates this from the left side, so it starts splitting in this direction, which means that if we run this program right now and provide a max split of 2, it's going to split this 2 times at most. So this is some special stuff. As you can see, it separated these 2, but it did not separate the rest because we said we're only going to separate the first 2 elements. And the reason I used max split here is because I wanted to show you that if we use rsplit with max split, it's going to do it in the opposite direction because it starts from the right side first. Next we have rstrip, which strips the text from the right side. So here we have text.rstrip and we want to strip Mario from the right side. And since we have two Marios here, it's going to remove this Mario right there. And now we will have an output of his name is Mario. 41, we have splitlines. So suppose you have some text and the text has some separators such as /n, which starts a new line. Text.splitlines is going to take each one of those lines and put it as an element into an array. So if we run this, we'll get remember to comment as two different elements in an array. Now you can specify this parameter keep ends to be true or false depending on whether you want to keep these escaped characters. Without it, you're just going to get the strings without the \n included in both of the elements. Number 42, starts with. Suppose you have a string that starts with L, you can check that by using the .startswith method, and it's going to check that Luigi starts with L, which is true, but Luigi does not start with F. And that can be proven by using this method. Number 43, strip. Suppose you want to remove Luigi from this string, you can just type in text.strip, and here we're just removing Luigi by inserting Luigi. So by running this, we will effectively remove Luigi. And this one works for both sides. So you can either remove pasta or Luigi, depending on your preference. As you can see, if we type in pasta dot, it will also remove pasta. Number 44, swapcase. Here we have a string that says Luigi has pasta, and let's just swap case that. The easiest way to explain this is to run it. Now we have Luigi has pasta in a swap case. Now, one that's really interesting in Python that can help you a lot in case you don't know how to write a title is the .title method. Here I wrote something that's called this is a title, and what this is a title do is make sure that each letter is uppercased in your title. So it's a simple way to make a title, and I think this is one of my favorite string methods because of it. Number 46, upper. Here we have some text that says hello there, and we just want to uppercase that. And if we run this, we'll get hello there in screaming characters. And finally, we have number 47, which is also the final method that we will be covering in this video, and that is zfill. So right now we have some text, and if we just run this as it is, you'll see that text is going to be filled with some zeros, just in case you have to add some zeros to your text. But anyways, those were 47 string methods that you can use in Python. Do let me know in the comment section down below if you learned something new or if there was something that I missed regarding these methods. This video took me 50 minutes to record, and it's actually even growing longer because of this explanation. But if you did enjoy the video, do consider leaving a like and a comment. I love to read those. But otherwise, with that being said, I also want to wish all of you a happy new year. I know this is quite late, maybe it's day 5 or day 6 of the year, but this is the first video I'm recording this year, so I thought I might as well mention it. Otherwise, with that being said, as always, thanks for watching, and I'll see you in the next video. Ooh.